We're going to focus on the organic reactions, and I'm going to keep the summary it's in your booklet, and it's also on that live worksheets with the organic reactions. And I always keep this with me when I'm teaching or something, just to remind myself of all the catalysts and the reactions, things like that. So it's a very good summary of everything that's happening in this section. So what I'm going to do one question that was one of your homework questions, page 285 in the chemistry booklet, and then I'm going to do the test question. I'm going to go through some common mistakes and things that happen here. Maybe before we do that, let's just do like a quick little summary of all the organic reactions, or the most important parts of it. So the most important part is if something is going from, let's say, saturated first to unsaturated. Saturated meaning there's only single bonds between all the carbons. Note, just carbons, not anything else. And unsaturated means double or triple. In this case, we only do ones with double bonds in grade 12. If that happens, then you're going from saturated to unsaturated, and that is a very specific type of reaction. If you're going from saturated to unsaturated, you're essentially kicking something out. So in this case, you'd be kicking out two hydrogens there, and those two bonds then go and form a double bond together in that case. So those two bonds became that bond. If this happens, you've kicked something out or eliminated something, and then it's called an elimination reaction. So that's the first type of different reactions in organic chemistry. The second type is addition. Now you'll notice addition is the exact opposite of elimination. And oftentimes what you can actually do is you can just reverse the arrow and then it becomes an addition reaction. So an addition reaction, you take something that is saturated, all single bonds between carbons. Not saturated, unsaturated, because it's the opposite. You take something that has double bonds between carbons and you add something into it. And what happens then is those double bonds break and they end up forming that. So you go from unsaturated to saturated. Now there's a whole bunch of things you can add here, just like there's a whole bunch of things you can remove here. So during an addition reaction, you have to go from something that's unsaturated to something that's saturated. That's the key, the biggest thing. Then there is substitution. And during substitution reactions, those are actually quite simple. You're literally not kicking something out, you're not adding something, you're just taking something away and replacing it with something else. And again, there's a whole variety of things that you could replace it with. So let's say, for example, you had a hydrogen there, just a normal alkane. So you have something that's saturated and it stays saturated. That's probably the biggest thing again. And then you add, let's say, a halogen or something like that. And what you do is you kick out the hydrogen and the halogen takes its place. And now it looks something like that. So elimination, you have to go from saturated to unsaturated. Addition, you have to go from unsaturated to saturated. And substitution, you have to go from saturated to saturated. That is the biggest thing to look at. And then you get all your different types of sub-reactions in each one of those. So elimination. Let's look at the different types of elimination reactions. Okay, so I've got my summary here so I can refer back to it the whole time. So the first type of elimination is one where, just simple, straightforward, you kick out hydrogen out of the reaction. And all those little reaction conditions, the catalysts, if it must be heated or heated under reflux, are actually very important. They don't seem very important when you start the section, but they are actually very important and they get asked a lot. Okay, so in this case, I like learning platinum for the elimination, because if you reverse the arrow and you do the addition reaction, platinum is also a catalyst. So instead of like learning all the different ones, like platinum, palladium, nickel with the addition, just learn the platinum, because it works both ways. It works for the addition and it works for the elimination. Now if you kick out just hydrogen, so I'm just going to draw the ones that I kick out just to make it look a little bit easier. If you kick out the hydrogen, those two single bonds become your double bond, and it looks like that. And then remember that you kicked out the hydrogen. And the name actually makes a lot of sense with what's being kicked out. So this is dehydrogenation. D if you're removing something, if you eliminate something. Dehydrogenation. Now, the opposite, if you just turn the arrow around, actually becomes the addition reaction. And then, like I said, platinum works as the catalyst as well. Okay, but we'll do that just now. Okay, the next elimination, you'll notice in the summary there's no dehalogenation. It's just not on the syllabus, so we're not going to do that. The next one is something, you start off with something that's an alcohol. Okay, doesn't matter where you put that OH at the moment. Then you kick out the OH. Now you can't kick out the two things from one carbon. So you have to kick it out from that one, and then let's say from that one. Okay, so that's what I'm going to kick out. So I end up, again, those two bonds join and become your double bond, like that. And then you kick out an OH and an H, which joins together and forms water. They might ask you to draw the structural formula for that, in which case it just looks like this. And same for this one. Okay, so you kicked out water. So this is dehydration. I always remember anything to do with water, adding water, kicking out water, the catalyst is always sulfuric acid. Okay, if you're kicking out water, it has to be concentrated sulfuric acid. Okay, otherwise this is not going to work. The last one, and I always think this is the most complicated one, it's got the longest name, so it's the one that is not just straightforward, you have to add something weird in for this one to happen. So this one, you start off with something that is a halogen, and you have to add something. So what you're adding is NaOH or KOH. Remember, these are strong bases. And remember that when you add these in your elimination reaction, you have to add them as concentrated strong bases. Remember in the lab worksheet, it says that there's a reaction in where you add a dilute of the sodium hydroxide or potassium hydroxide, and that changes the whole way the reaction takes place. It then actually becomes a substitution reaction. Okay, so what happens then is you kick out a halogen, you kick out a hydrogen. Okay, that's why it's dehydrohalogenation. Okay, again, those two little bonds join and become a double bond. Okay, then you also have your Na that's still there. You still have your Cl, you still have your OH and your H. So what happens is that Na bonds with the Cl and forms NaCl, and the OH bonds with the H and forms water. So dehydrohalogenation. Also remember that's the longest name, the most complicated one, it has the most reaction conditions. So this has to be concentrated, the base, and you have to heat this under reflux. Okay, if you're not sure what that means you're heating it, it evaporates, it cools, it condenses. Again, it goes to the bottom, you heat, evaporate, cools, condenses. So reflux means like a process of flowing.